Welcome to this explainer. Today we're undertaking some truly high-stakes, microscopic detective work. We're pulling back the curtain on the invisible war that's constantly being waged right inside the facilities that make our ready-to-eat food. It's a relentless battle against unseen threats that can completely shut down massive food plants and, more importantly, put our health at serious risk. We're talking about the gritty world of food hygiene and cross-contamination. So let's dive right in.
Let me challenge you right out of the gate here. Does a surface that looks perfectly clean actually mean your food is safe? Think about it. You look at a gleaming stainless steel food conveyor belt, it's sparkling under the factory lights, it's gotta be safe, right? Well, the answer is a definitive, resounding no. In the food industry, a visual inspection is quick, it's simple, but relying on it alone, that's a total recipe for disaster. What we can't see is very often what hurts us the most.
And this 38% figure perfectly illustrates exactly why that is. Cross-contamination contributes to roughly 38% of all foodborne outbreaks. That is nearly 4 in 10. To put that into perspective, in almost half of the cases where people actually get sick from their food, the bacteria just hitched a ride. It hitched a ride on a surface, a hand, or a piece of equipment that simply wasn't as clean as it looked.
Section 1. The hidden contamination threat. Let's figure out what we're actually up against.
What's absolutely fascinating here is the clear distinction between the two types of bacteria we're fighting. On one hand, we have transient microbes. You can think of these guys as tourists. They're just passing through. And honestly, they can be pretty easily washed away with your standard everyday cleaning. But the true threat? The ones keeping food safety experts up at night? Resident microbes. These are the entrenched invaders. They undergo intense stress response adaptations. They hunker down, they adapt to the chemical cleaners, and they literally establish a permanent home right inside the facility.
And how exactly do those resident microbes establish that permanent home? Well, they use biofilms. A biofilm is essentially a microscopic fortress. The microorganisms band together and secrete this incredibly tough protective matrix around themselves. It's literally like they're pouring biological concrete over their entire colony. Once they are tucked safely inside this biofilm, they become highly resistant to the normal cleaning chemicals and disinfectants that would otherwise easily wipe out those transient bacteria.
So, let's meet the ultimate villain in this invisible war, Listeria monocytogenes. Listeria is an absolute master at building those fortresses. It doesn't just pass through a facility, it colonizes it. It settles into these highly specific, really hard-to-reach spots in a processing area and just sets up shop. And from that hidden bunker, it causes continuous, or sometimes occasional, contamination of the food that's just rolling down the line day after day.
Moving on to Section 2, Anatomy of an Outbreak. Let's look at some real crime scenes. Take a look at this case file from a Swiss sandwich plant. They found Listeria in 70 different environmental swabs taken all around the facility. But here is the truly terrifying part. 78% of those isolates belong to a single, identical genetic strain, meaning this wasn't new bacteria randomly coming in from the outside. No, it was traced back directly to their slicers, their conveyors, and the bread-feeding machines. And that single, stubborn strain had successfully persisted on those slicers for more than 9 months. 9 months! It took a massive, complete revision of their cleaning programs to finally break that cycle.
Or, consider this chilling case from a U.S. dairy plant. Listeria was discovered right near the areas where hoses were being used to clean the equipment. The contamination matched the exact strain of a major outbreak. And the financial and business consequences here? Absolutely devastating. The very following year, the entire plant completely closed down. The economic impact of poor cleaning isn't just a slap on the wrist or a fine. It can literally mean the end of a business. Period.
It really all comes down to one devastatingly simple truth. Poorly maintained tools equal a source of contamination. Just think about the bitter irony in that U.S. dairy case. The very tools that were meant to sanitize the facility, the cleaning hoses themselves, actually became the vectors. They were the things spreading the lethal bacteria across the floor and straight into the finished product area. Crazy, right?
Section 3. The Science of Cleaning. Let's see how we fight back.
One of the biggest misconceptions out there in food safety is using the terms cleaning and disinfecting interchangeably. They are actually completely distinct stages. Cleaning is strictly the physical removal of soil, literally getting the matter out of the way. Disinfection, on the other hand, is the actual chemical reduction of those invisible microbes. And here is the absolute golden rule of food safety. You absolutely cannot successfully disinfect a surface until you've successfully cleaned the soil off of it first. The soil physically blocks the disinfectant from ever reaching the bacteria.
So what exactly constitutes this soil that we so desperately need to remove? Well, leftover organic and inorganic matter is essentially an all-you-can-eat buffet for microbes. We're talking food residues, fats, proteins, dust, minerals. It's the exact nutrient source that allows bacteria like Listeria to thrive, to establish their colonies, and to build those incredibly stubborn biofilms in the first place.
Section 4. The Detective Toolkit. How do we actually find these microscopic fortresses?
One of the absolute most popular tools in the industry is visual ATP testing. It looks for biological residue by essentially measuring light, producing a result in what we call relative light units, or RLUs. Now, the huge pro here is that it's incredibly fast. We're talking 10 to 30 seconds right there on site. But it has some pretty major blind spots. It can be easily thrown off by certain food types or cleaning chemicals, and critically, it offers absolutely no direct correlation with actual microbial counts. It tells you if the soil is there, sure, but it doesn't tell you if the lethal bacteria are there.
So, to find the actual bacteria, we have to rely on microbiological swabbing. But prepare yourself for this incredibly shocking number: 0.1% to 25%. That is the typical recovery efficiency rate for traditional swabbing. That means even when highly trained professionals aggressively swab a stainless steel surface, they might be leaving behind anywhere from 75% to 99.9% of the bacteria. These microbes are just incredibly stubborn. They stick to the surface and completely refuse to be picked up by the swab.
Okay, and then we have the ultimate plot twist in our microscopic true crime story. VB incies, viable but non-culturable bacteria. These are bacteria that are completely alive, entirely viable, and highly dangerous, but because of environmental stress, they simply refuse to grow on the testing plates back in the lab. This is a massive, massive danger because it leads directly to false negative results. The lab says, hey, the facility is clear, but the deadly bacteria are still sitting right there on the conveyor belt, basically just playing dead.
Because no single tool is perfect, facilities simply cannot rely on just one method. They have to use an integrated defense strategy. They start with step 1, visual inspection, to find the obvious, visible soil. Then they move to step 2, rapid ATP testing, to detect the invisible organic residue. And finally, step 3, microbiological swabbing, to actually hunt down and target the specific pathogens. It really takes all three of these working perfectly in tandem to effectively hunt down the contamination.
But let's be real, you can't test absolutely everywhere all the time. Facilities have to be smart. They have to map out their high-risk targets. They focus heavily on hand contact surfaces. They dig deep into the cracks and crevices where those sneaky biofilms love to hide. They rigorously test their own cleaning equipment so it doesn't accidentally become a vector itself, and they closely monitor their CIP, or clean-in-place, rinses.
Section 5. The future of food safety. Where do we go from here?
So how exactly are we upgrading our defenses in this war? Well, we're shifting toward much more rapid testing methods. We're talking about advanced ATP and molecular detection that can actually spot low infectious dose pathogens pretty much instantly. We're seeing way more flexible sampling tools that can finally get deep into the machinery, right where those 9-month-old biofilms are hiding out. And perhaps most importantly, we are seeing fully integrated, data-driven systems that can track contamination trends over time, effectively warning a facility way before an outbreak even has the chance to happen.
Which brings us to our final thought for today. Knowing about this massive, invisible war being fought on every single slicer, every floor drain, and every conveyor belt, how are you going to look at your next ready-to-eat meal? The food on our plates isn't just manufactured. It is fiercely protected by a massive, completely unseen scientific effort. It's just this endless, relentless cycle of cleaning, hunting, and adapting to keep those microscopic fortresses at bay. Thank you so much for joining me on this explainer, and as always, keep your curiosity sharp.